Hello everyone. Welcome to the Smart Learning Academy. And today we're going to start chemistry, advanced chemistry, and our topic is organic chemistry. Yeah. So tulisema kwamba tutakuwa na introduction, and our introduction contains two parts. And the first part, it has atomic structure of carbon. And today we're going to start with this atomic structure of carbon. And in the atomic structure of carbon, we have to see its atomic orbitals. Yeah. Kwa inabidi tujue kwamba carbon ni element number 6. Carbon is element number 6. Having or being element number 6 means it has 6 electrons. 6 electrons. Na kwa sababu ni element number 6 na ina electron 6, it means that it has more than one orbital. Has more than one orbitals and those orbitals are 1s orbitals, 2s orbital, and 2p orbital. So we want to learn about, or we want to see their structures. One s orbital is spherical in shape, and actually all s orbitals are spherical in shape, but the 1s orbital is smaller than the 2s orbital. So the 2s orbital will be much larger. So 1s, 2s, and 2p orbitals are dumbbell in shape. Dumbbell is this way. These are dumbbell. So we have 3p orbitals. We have 3p orbitals. 3 orbitals aligned in axis. This is x-axis. This is y. Sorry. This is y-axis. And this is z-axis. So the first dumbbell is aligned with x-axis. This one. The second one is this way, aligned with y-axis. And the last one is in z-axis. So these are shapes of atomic orbitals, not only of carbon but of any atom. Any s orbital is spherical in shape, but the size will depend on this s is in which shell. If it is in the first shell, it is the smallest one. If it is in the second shell, it will be much larger compared to the one in first shell. So it will depend in which shell, but all s orbitals are spherical in shape. Also, all p orbitals are dumbbell in shape. And if within one shell, they are called degenerate orbitals and they have same amount of energy. Example, these are degenerate orbitals. There are 3 orbitals and they have the same amount of energy. They are called degenerate orbitals. So we have seen the shape of atomic orbitals. Yeah, energy level. About the energy level, let's see the energy level. This energy starts from here, which is 0, and there is a ground state. Here's a ground state. So the first s orbital is in here. Let me call it 1s orbital. 1s orbital had the lowest energy among all atomic orbitals present or available in any atom, and it followed by the 2s and followed by 3p. So this is 2px as I showed you, this is 2py, and this is 2pz. So the total of 5 orbitals, and the first orbital is occupied by 2 electrons. 1, 2, yeah, and the 2s also by 2 electrons, because we'll come to learn this. Let me just put them here. So these are energy levels of orbitals. The first 1s orbitals having the lowest energy, the second, which is 2s orbitals, having higher energy compared to s, and this also has lower energy compared to p orbitals. These 3p orbitals have equal amount of energy, and their name is degenerate orbitals, since they have same amount of of energy. Let's come to how we fill these orbitals. We fill them according to the three principles. This is the first one, second, and third one. So carbon 6, these are orbitals. You know this stuff. I'm just refreshing your knowledge. Yeah, this is 1s, this is 2s, this is 2px, this is 2py, this is 2pz, and we have 6 electrons. So the first one, Aufbau principle, tell us that fill up lower energy atomic orbital. Lower energy atomic orbital. The lowest one here is 1s. So I will take electrons and fill in 1s. But one orbital can contain a maximum number of 2 electrons. So here will be this way. And why I'm just directing this in opposite side or opposite spin? Because how h orbitals 2 electron, okay, fine. H orbitals contain a maximum number of 2 electrons, and these are 2 electrons. But also we know that no orbital should have electrons which are having the same spin. So we directed them oppositely. Yeah. So if we have put here 2 electrons, it means that we remain with 4 from these 6 electrons. So we're gonna take also 2 electrons and fill up in the 2s orbital. So 2 electrons. Now we remain with 2 electrons. If we remain 2 electrons, we have 3 orbitals having the same amount of energy. If these orbitals are having the same amount of energy, the way of filling them up is singly, being unpaired first, then pair them if we have remained electrons. So if it is unpaired, it means that we fill this way, unpaired in the same spin. If we had more electron, it means that we're gonna fill also with this. And then if we had more, then this way. But we only have 2 electrons remained, so will be this way. Sha sha. So this is how electronic configuration of carbon is written. So we have 1s2, 1 stands for the first shell, and s type of orbital. So it's 1s2, 2 stand for electrons, and we have 2s2, which is this one, 2 shell and s type of orbital, 2 electrons, and 2p, how many numbers? We have 2. So it's 1s2, 2s2, 2p2. This is the electronic configuration of what? Of element carbon. Thank you.